lesson 10.4, inscribed angles. As a warm-up, a little review of what we talked about on Tuesday in 10.3 with congruent chords. If we don't let these circles throw you off that they don't have a center, it bothers me a little bit, but it's okay. If we have two chords that are the same length, that's what they're showing us here. That means the arcs they form are going to have the same measure or the same length. They're also congruent. So you would set up your equation like so, and you would get x to be 45 for that one. Okay. Number 2 is similar, but this time they're showing me these arcs that the chords are forming are congruent, which would mean these chord lengths are congruent as well. So you should have set those equal to each other. Let's see. I got x to be 8 for that one. Any questions on those? All right, next two. What I don't love about these drawings is they should show you that, well, they're showing you they're equidistant. These chords are equidistant from the center, which is good, but they should be showing you that they're the shortest distance. There should be a little right angle marked there, assuming that it's the shortest distance, but you can kind of tell that. We talked about this as well. That means that these chords would have the same length if they're equidistant around away from the center, meaning they would form congruent arcs as well. Those arc measures would be the same. Sorry, I meant to put equals there. Okay, that's how I got x to be 9. Okay, this one's similar. Equidistance from the center. Technically the shortest distance, meaning these chords would be congruent or have the same length. All right, I got x to be 13 for that one. Okay, how'd we do? Sorry, was that too easy? Libby, could you light it real quick, please?
Oh my god.
Right? Thank you. Okay.
Grab the header signs for me.
All right, bring it up here. What is it for?
I have AP testing now.
Oh, that's right. Okay. You were missing a quiz. So you'll just have to make that up, okay?
Sounds good.
Good luck on your A-push exam.
Thank you.
All right. Here's a couple vocab for you. We talked about inscribed polygons. That is when you have a polygon where its vertices all lie on a circle. So an inscribed angle, kind of connecting our vocab with inscribed and connecting our vocab with an angle, is when our vertex lies somewhere on the circle. And the two segments that form the angle, endpoints are on the circle as well. Or another way to say that is that these two segments that form this angle are chords. Okay, everybody see that, what I just highlighted in green? So this right here we would call an inscribed angle, angle CED. So these inscribed angles form what we call an intersected arc. Think of it just intersects or intercepts the circle at those points C and D, and it forms this arc. So arc CD would be the intercepted arc. Not to get this confused with the central angle. The central angle is the angle from the center to two endpoints in the circle. Okay, it would also form this arc, but the central angle is different than the inscribed angle. Okay, we've already talked about these. There's a relationship between the two, though, and that's what we're going to talk about next. We basically have 4 theorems we're going to talk about today. Here's the first one. If an angle is inscribed in a circle, we just talked about what that means, then the measure of that angle is exactly 1/2 the measure of the intercepted arc that it forms. Okay, so in this picture right here, this is an inscribed angle, right? Its vertex is on the circle. And the segments that are forming this angle are chords. It's forming this arc which we know whatever the central angle is, that has the same measure as the arc, right? So that inscribed angle is exactly half of whatever the central angle is, which is the same as the measure of that arc. Okay, I have a visual to show you this in a second. So the measure of angle 1, this theorem says, is always going to be half the measure of arc AB, or of its central angle, because we know those are the same. We can use this the other way. Maybe we know the measure of this arc. Actually, maybe we know the measure, I guess, more probably of the angle. That measure of the arc is going to be double the measure of the angle. We'd probably use that more that way. If we know what this angle is to find this measure, we just double it. Okay, here's the visual I have for you. So the theorem says both of those. You can use it either way. Those equations technically say the same thing, just written two different ways. So here's my visual. So it says I right here is the value of the inscribed angle. So the inscribed angle is the orange one. C is the measure of the central angle. That's the purple one. So they're telling you with these angle measures, so you can see that the central angle is double the inscribed angle. And I can move A around, but notice how it's not changing the intercepted arc, right? Even if I slide A around, it's still forming that same arc, so those angle measures don't change. Now if I let's slide B. Let's make that intercepted arc like a little smaller, like that. Is that inscribed angle still half of that central angle? Yes. Half of 78 is 39. Let's make it really big, like this. Okay, this time my inscribed angle right here, angle A, 87 degrees. Central angle, 174, still half. Okay, so no matter where you're at in your circle, that will always hold true. And again, remember, the measure of this central angle is the same as the measure of this arc. That's how you measure the arc. You're measuring the angle it forms. All right, let's try this problem. It's a good little problem. I have one circle, and part A wants me to find the measure of angle X. So angle X is an inscribed angle, and the intercepted arc, or the arc it's forming, is 86 degrees. That's what they're showing you. All right, so I know this inscribed angle is going to be half of that arc measure. So angle X is going to be 43 degrees. Okay, that relationship will always hold true. This one kind of goes the other way. This time they want us to find the measure of arc YX, this arc right here. All right, so I look and I see this inscribed angle that's forming that arc is 52 degrees. And I know the arc measure is going to be 2 times that angle. So 2 times 52, 104. Make sure you put degrees. Okay. All right, that's one of our theorems. Got it? Pretty simple. I don't want to say like really something you have to memorize. I mean, it makes sense, kind of, if that this angle is obviously going to be smaller than if I were to draw its central angle right here, which is from the center. That's obviously going to be larger, and it just happens to exactly be half. Okay. I think there's a proof of this one in your book too, if you're interested. Here's our next theorem. This one's kind of fun. This one is easy to conceptually understand. If we have 2 inscribed angles and they're forming the same arc or congruent arcs, then those angles have to be the same measure. Okay? So here's one inscribed angle, angle C. See how it's forming arc AD? I could draw another inscribed angle that's forming that same arc, so joining those 2 endpoints like angle B. So because those inscribed angles have to be half of this measure, they have to be the same thing. That's what this theorem says. All right, so as long as angle B and angle C both intercept the same arc or congruent arcs, arc AD, then those angles have to have the same measure or are congruent. Okay. So let's try this example. I have this circle here. They want me to find the measure of angle R. So I'm looking here and I see this inscribed angle is angle R. Okay, and it helps you can kind of like sketch in the arc it's forming. And I'm like, okay, it's 12x minus 13. But then I see this other inscribed angle, angle S, is creating the same arc. And since both of those inscribed angles, exactly half of that measure, they have to be the same thing. So we're just going to set them equal to each other and solve for x. X is 5. What do I have to find? Angle R, meaning the measure of angle R. Minus 13, 47. Yes. 47 degrees. Okay, any questions? All right, we're gonna do one more like that. So this one can look confusing to students. They're like, whoa, are these a bunch of triangles? What's going on here? It's a lot easier than that. They want us to find the measure of angle A and the measure of angle C. I'm going to start with the measure of angle A. Is this inscribed angle right here? It's forming arc what? CD. Yep. What other inscribed angle is forming arc CD? B. See that? Those have to be congruent. X is 4, meaning the measure of angle A is 20 degrees. So what's the measure of angle B? 20 degrees. They're congruent. Don't even have to do any math. Okay. Angle C. So I'm looking at angle C. Is this inscribed angle? Forming arc AB. Another inscribed angle forming that same intercepted arc. Angle D. Have to be congruent. So let me go to each other. Y is 10. Meaning the measure of angle C is 47 degrees. Okay. Basically, halfway through our lesson. That's 2 of the 4 theorems you gotta know. I like that one. Pretty easy to visually understand that. Okay. I want you guys to try this next problem on your own. There's 2 ways you can do it. So show your work. I'm going to pick 2 people to put on the dot cam and be featured in my YouTube video, which gets a lot of views. So
JV baseball should be
here's your
resumed.
chance.
So get ready and load the man. Thank you.
Let me give you your worksheet. Are you a JV baseball team walker?
Yeah. Yes.
Are you a waist size? Good luck. This one's kind of more like the first theorem we talked about. There's one way to do it.
Yes. Perfect. 2 different ways.
Nice. All right, looks like most of you got this as I'm walking around. Okay. So first, let's look at Brianna's. I feel like I gotta turn the light on. Oh, you can see that. Okay, so one way we could have done this was we know this arc length has to be double this inscribed angle. So you could have doubled that inscribed angle. That has to be equal to the arc measure. Solve it, you get x to be 5. Anybody do it that way? Okay, nice. Alex did. I did it the same way Alex did, actually. Same idea here, but she said the measure of angle F is exactly half of this arc measure. So she took half of the arc measure, and she knew that angle had to be equal to half of that, and she also got 5. Oh no. They're brand new. They're gonna be a tray next year, so I don't drop these as much because they're not cheap. Okay. Good job, ladies. Thank you. Any questions for Brianna or Alice? Good job. All right. Next theorem. Okay, this is kind of a review. We've talked about what an inscribed polygon is. Here's a little picture. I kind of mentioned this, I think, at the beginning of the lesson. All the vertices line the circle. So if I have an inscribed triangle, okay, but what I want you to think of it is an inscribed angle intercepts an arc that forms a semicircle, okay? So look here at angle G. See how the arc it forms is exactly a semicircle, and if I were to connect those points, it would form a triangle, and that length would be a diameter. What this theorem says, if your arc is a semicircle, then the measure of that inscribed angle is going to be 90 degrees. Which makes sense, because that's half of 180, right? Okay. So if you were to form a triangle, it's going to be a right triangle, and this side is always going to be the diameter. Okay? So if you know that inscribed angle is 90 degrees, then we know that arc is a semicircle. And if I were to connect those segments, FH will be a diameter. Okay. So the only way we can form a right inscribed triangle is if one of the side lengths is a diameter. It's kind of another way of thinking about this. Here's my visual for this one on Desmos. Okay. So basically, as long as this is a diameter or the intercepted arc is a semicircle, like this is always going to form a right triangle, okay? Which makes sense because the inscribed angle has to be half of the semicircle. I could even move it. This doesn't let me, but you can move it around this side. If that holds true, it's going to form a right triangle. Okay. Oh, I already did that one. So let's try this one. Find the measure of angle B. Okay. Well, right now, I'm looking here at angle C, and I see it's an inscribed angle of this semicircle, or they're showing me that it forms that diameter. So I know angle C is 90 degrees. Okay? So if you see this inscribed triangle, I'll highlight it in green here. I have angle A, which is x plus 4. I have angle B, which is 8x minus 4. And then I have angle C, which is a right angle. So two ways we could set this up. You could do all of these angles have to add up to how many total degrees in this triangle? 180, or these two have to total 90. Okay, whatever we want to do it. I'm going to do it as 90 so you can remember that this is just a triangle. Plus angle B, plus angle A. Form a triangle and have to add up to 180 degrees. X is 10, meaning the measure of angle B, 8 times 10 minus 4. We get 76 degrees. Okay. Last theorem. That's pretty straightforward. If we have a quadrilateral that's inscribed in our circle, then the opposite angles are going to be supplementary. Okay, here's why. If you quick look at angle L, that has to be, well, in this case, if it lies like this, that'd have to be like 90, right? Just in this picture. And so would this one, but no matter where they're at, those two have to total 180 with those arcs that they're measuring, even if they don't lie right on the diameter. Okay, so my pair of opposite angles here would be angle L, angle N. I'm not saying they're always both going to be 90, but we know that they're supplementary. Ooh, maybe I already said this. Do you guys remember what supplementary means? Add to 180. Good. S, straight angle, 180. So angle L plus angle N are going to total 180. Those are opposite angles. K and M, also opposite angles. Those are going to add up to 180. Okay, we're going to try two examples of this. An insignia is an emblem that signifies rank, achievement, membership, and so on. The insignia shown is a quadrilateral inscribed in a circle. Find the measure of angle S and the measure of angle T. Okay, without doing any math, really, what's the measure of angle S going to be? 90. The opposite angles have to be supplementary. The opposite one is a right angle. That's a right angle. Angle S also has to be 90. Good. Okay, that doesn't mean they're always each going to be 90. Now they want me to find the measure of angle T, which its opposite angle is U, so I'm not going to set them equal to each other. They're supplementary. I'm going to add them together and set them equal to 180 degrees. Solve this quickly. X is 8, which means the measure of angle T is 8 times 8 plus 4, 68 degrees. If you want to find U, take 180 minus that, and then you can find U. And then you know all the angles in that quadrilateral. How fun. Okay, any questions? Last problem. I kind of like this one. You have to find the measure of angle C and the measure of angle D. And they label C as 2x, but we know its opposite angle is 58 degrees. So I don't really need to set up an equation because I know those have to add up to 180. So I don't really need to use that 2x because they tell me this one's 58 degrees. So what's 180 minus 58? Anybody? 122 would be the measure of that angle. Didn't even need to use that 2x value. You still could. You could still do 58 plus 2x equals 180. It's just going to create a little bit more work for yourself. Then you're going to solve x. Then you're going to plug it back into C. All right, last one. B and D, opposite angles. Those are supplementary. meaning they add up to 180. $32 for y, we have to find d. 2 times 32 plus 16. That one is 80. So what would angle B be? 100. Good. Okay. You understand? Told you it was a nice lesson today. That's a wrap. And only 4 lessons to go.